Have you ever gazed up at the night sky and wondered what exactly is the universe? This vast expanse of space has long held a sense of mystery and fascination for humankind. Since time immemorial, we've sought to understand the cosmos's workings, its grandeur, and the place we occupy within it. From ancient stargazers to modern scientists, our curiosity is as boundless as the universe itself. Today, we'll delve into the intricacies of the universe and attempt to unravel some of its mysteries. Our journey begins about 13.8 billion years ago, with a phenomenal event known as the Big Bang. No, it wasn't an explosion as the name might suggest. Rather, the Big Bang was a rapid expansion. Picture, if you will, a balloon inflating. This is more akin to what happened at the birth of our universe. From an incredibly hot, dense point known as a singularity, the universe began to expand. Not into anything, mind you. There was no outside for the universe to expand into. Instead, the universe created its own space and time as it grew. This singularity was smaller than an atom, yet it contained all the matter and energy that would become everything we know today. In the first fraction of a second, this matter and energy began to cool and spread out. As it cooled, the fundamental building blocks of matter began to form. Quarks and leptons, the tiniest particles we know of, started to appear. As the universe continued to cool and expand, these quarks and leptons began to combine to form protons and neutrons. These protons and neutrons are what make up the atoms that form everything in the universe today. From the stars in the sky to the cells in your body, everything can be traced back to this moment of creation. And what about energy? Well, that was there from the start too. In fact, matter and energy are two sides of the same coin. They're interchangeable, as Albert Einstein famously showed in his equation EMC squared. This energy, along with matter, was spread out during the expansion, creating the diverse universe we see today. But the universe didn't stop expanding after the Big Bang. It's been growing ever since. And as it grows, new space is created, leading to the vast, ever-expanding universe that we are still trying to understand today. So from a singularity smaller than an atom, our universe was born and has been expanding ever since. But what exactly is the universe made of? It's a blend of matter, and dark energy. Imagine a cosmic cocktail, a universal blend that gives shape to everything we know and far beyond. This cocktail consists of three main ingredients: matter, and dark energy. First, let's talk about matter. This is the stuff we're familiar with. It's everything we can touch, see, smell, taste, or hear. It's the stars, planets, galaxies, and even you and me. Matter is what scientists call baryonic because it's made up of baryons, protons, and neutrons. It's the visible part of the universe, yet it only makes up about 5% of the total. Next on the list is dark matter. Despite its ominous name, it's not something out of a sci-fi horror flick. Dark matter is simply matter that we can't detect directly. We can't see it, hear it, smell it, taste it, or touch it. But we know it's there because of the gravitational effects it has on the matter we can observe. It's estimated that dark matter makes up about 27% of the universe. And now we come to the most mysterious ingredient of all: dark energy. This is a form of energy that permeates all of space and is believed to be the reason behind the accelerating expansion of the universe. It's a strange concept, isn't it? An energy that we can't detect directly, yet it's pushing galaxies apart at an ever-increasing speed. Dark energy is thought to account for a whopping 68% of the universe. These cosmic ingredients, matter, and dark energy, are what make up our universe. They influence its shape, size, and even its future. They're the unseen hands molding the cosmic clay, shaping the universe as we know it. Although we can't see dark matter and dark energy, they constitute about 95% of the universe. The unseen, it seems, holds the greater part of our cosmic reality. The universe is not a chaotic jumble. It has a structure consisting of galaxies, clusters, and superclusters. Imagine the universe as a cosmic web. This web is woven with threads of dark matter and gas, dotted with galaxies like shining beads. These galaxies are not scattered randomly. They are held together by gravity, forming groups known as clusters. These clusters can contain hundreds, sometimes thousands of galaxies. But the cosmic web doesn't stop there. These clusters of galaxies are also gravitationally bound, forming even larger structures known as superclusters. Superclusters are the largest structures in the universe that we know of. They can stretch over hundreds of millions of light years, containing tens of thousands of galaxies. As we traverse this cosmic web, we encounter an array of cosmic structures. We find galaxies swirling in a cosmic dance, clusters of galaxies huddling together, and superclusters strung out across the universe like cosmic pearls on a necklace. Each structure, from the smallest galaxy to the largest supercluster, plays a part in the grand architecture of the universe. Among these colossal structures, one stands out: the Hercules Corona Borealis Great Wall. This is the largest known structure in the universe. It is a vast supercluster complex that stretches over 10 billion light-years across. To put that into perspective, if you were to travel at the speed of light, it would take you 10 billion years to cross it. The Hercules Corona Borealis Great Wall is a testament to the universe's grand scale and intricate structure. It reminds us that the universe, in all its vastness and complexity, is not random or chaotic. It is structured, ordered, and governed by the fundamental forces of nature, including gravity, which shapes and molds the cosmic web in which we find ourselves. So, as we gaze out into the cosmos, let's remember that we are not just looking at a random assortment of stars and galaxies. We are witnessing the cosmic web, the grand structure of the universe. The universe, it seems, is anything but random. The universe isn't static, it's expanding. But not just expanding, it's accelerating. Let's delve into the captivating evidence that supports this claim. Back in the early 20th century, astronomers like Vesto Slipher and Edwin Hubble made a startling discovery. As they observed distant galaxies, they noticed something peculiar about the light they emitted. It was redshifted, meaning it was stretched to longer, redder wavelengths. This redshifting of light is similar to the way a siren's pitch changes as it moves away from us due to the Doppler effect. This suggested that these galaxies were moving away from us. The more distant the galaxy, the more its light was redshifted, indicating it was receding faster. This led to a profound conclusion. The universe is not static but expanding. Every galaxy in general is moving away from every other galaxy. But that's not the end of the story. In the late 90s, observations of distant supernovae, the spectacular explosions of stars, revealed something even more astonishing. The universe's expansion wasn't slowing down as one might expect due to gravity. Instead, it was speeding up. Enter dark energy. This mysterious force, making up about 70% of the universe, is believed to be the oomph behind this acceleration. It's a bit like blowing up a balloon. As more air, or in this case dark energy, is added, the balloon, or our universe, expands faster. Dark energy remains one of the biggest mysteries in cosmology, invisible and undetectable, yet its effects are seen in the cosmic dance of galaxies moving apart. It's a force that seems to defy gravity, pushing galaxies away from each other, causing the universe to expand at an accelerating rate. So the universe continues to expand at an ever-increasing speed. Our cosmic story is one of constant change, driven by forces we are just beginning to understand. The universe is a symphony of motion, a ballet of galaxies, each dancing to the music of physics. And the dance goes on, with the universe playing both the music and the dancer. So what's next for the universe? Will it keep expanding forever? The future of the universe is a subject of intense speculation and study. There are three main theories that scientists are currently considering. First, we have the Big Freeze. This theory suggests that as the universe expands, it will gradually cool down. Stars will burn out, galaxies will drift apart, and all matter will eventually decay into radiation. In this scenario, the universe will become a dark, cold, and lifeless place. Next, we have the Big Crunch. This is essentially the reverse of the Big Bang. According to this theory, the universe's expansion might slow down, stop, and eventually reverse. All matter in space could collapse into a single point, possibly leading to another Big Bang and a new universe. Finally, there's the Big Rip. Imagine the universe's expansion accelerating to such an extent that everything, galaxies, stars, planets, and even atoms, gets torn apart. A frightening prospect indeed. Each of these theories is based on our current understanding of the universe and its laws. But remember, our knowledge is constantly evolving. As we learn more, these theories may change or new ones may emerge. The future of the universe is still a mystery, but isn't that what makes it so fascinating?